Level is rainfall. Okay. What do you see in this scatter plot? What do you see? Do you think that the linear term is okay or non-linear, right? You can see that there's some curve like this, right? So we should consider the second order model. Okay. So if I fit the first order model, I get the blue line. And for second order model, I get the red line. You see that which one is fit better? The second order model, right? Fit better than the first order model. So how to get the results in SPSS? And this is new that suppose that your data set contains only two columns. Okay, the first column is a con yield, and the second column is rainfall. But then you have to include the square term, right? Then you have to transform the variable first. Okay? So you go for transform and then computed variables. What you have to specify is the target variable, which is the column name, okay, the new column name. And then you have to put the numeric expression, okay? And here we use rainfall times rainfall. Here's a rainfall square. And here's an x squared. And then we click OK. Then you get the new column. The last one is your new column. Okay. Which is the square term of the rainfall. So now you get the rainfall square column. Then you can use a regression. Tools to get the coefficients. Here you see that the term rainfall square is significant. Okay, that means that the second order term is appropriate, right? Any questions? What about beta zero? Okay, in this case,
still keep it.
we have constant to be the
Should be zero.
B0 is not significant.
Yeah, yes.
What you are going to do?
Reject.
Just keep it.
Reject.
Reject the now?
Yeah, actually reject.
Actually, where do you reject?
No, not reject. Reject.
Reject?
No, reject.
Where do you reject? Yes.
Mean zero.
So we clearly the slope variables are all significant, but the intercept term is not significant. But we said that usually we ignore it, right? We ignore it. So we still
Minus 1.
get this equation. But should you interpret this B0? Does it make sense to interpret this B0? So to interpret this B0, you said that the average on U, right? When rainfall is equal to 0 is -5. It's about -5 on average. Does it make sense? No, right?
No. Minus.
Can con U equal to negative value?
No.
No. But should we put that the rainfall is 0 should have the U equal to 0? maybe it's also not make sense. Okay, so and I believe that there shouldn't be some year that have rainfall equal to 0, right? Then you cannot interpret the B0 here. It's not appropriate. But we still ignore the constant, even though even though this term is not significant, we still put it in the model. Okay. So far we have talked about the case when independent variables are quantitative variables. But sometimes independent variable is qualitative variable. For example, male and female, something like that. This is an example of qualitative variable, right? So if you deal with the qualitative or nominal independent variables, we need a dummy variable. Okay. Dummy variables sometimes are called indicator variables. Okay. And it can take only two values, either 0 or 1. Okay? Either 0 or 1. And normally, suppose that we have a nominal variable with k classes, okay, then we need k minus 1 dummy variable. For example, suppose in college, there's a freshman, right? Sophomore, junior, and senior. So there are 4 classes. But when you define a dummy variable, you need only 3 dummy variables. It's always k minus 1. Okay? In this example, this should be constant. Okay, so the response variable is pi sales and x1 is price, but price is a quantitative variable, so we don't have to do anything with that. But x2 is a holiday variable, and it can take value 1 or 0. It's 1 when a holiday occurs during that week, and 0 otherwise. Okay? So in this case, we're going to fit this model. And you can see that what we assume here is that they have the different intercept term but the same slope, right? Because for holiday, that means that x1 is equal to 1. Okay, so we have this equation, okay, for holiday. And then if I move B2 to the front, this can be viewed as a new intercept term. And then translate on x1. And if there is no holiday during that week, that means that the x2 equal to 0. And then we have the different intercept term, but same slope. Okay, but the same slope. And we can test whether beta 2 is equal to 0 or not. If we reject the null, then we can say that the holiday has a significant effect on pi cell on Y. In this case, how can you check whether the different intercept term is appropriate or not? Actually, you can use a scatter plot, right? You plot one for holiday, right? And you might get something like this. and then you plot one for when there is no holiday. Okay. And if you see that the slope can assume to be the same, except the intercept term, then this model is appropriate. Okay. Suppose I do the overlay plot, and I have something like this. This is the blue line is called no holiday. Then the model in the slide is not appropriate anymore, right? In this case, you should allow that the slope should be also different, right? So how do we do? So we have x1 to be price, x2 to be indicator variable, right? 1, 0, and otherwise. Actually, you can include x3, and then x3 is the interaction term, or you use x1 times x2. Then your model is 1x1 plus b 2x2, and then plus b3, x3, which is the interaction term between x1 and x2. Right? Then from holiday, what do you get? Holiday is when x2 equals to 1, right? So you have beta 0 plus beta 2x. And then plus b1 plus b3 x1. And then when there is no holiday, you have y hat equal to b0 plus b2x b1 x1. So if you include the interaction term, you can allow that these two lines can have different slope. Or you can fit this model first, right? And then see whether that B3 is significant or not. Okay? So how to interpret the regression coefficient for dummy variable? Here suppose that B2 is 15. Right? We can interpret as that on average sales were 15 times greater in weeks with a holiday than in weeks without a holiday, given the same price. Okay, this is how you interpret the regression coefficient for dummy variable. And another example is used car dealer. Okay? So Y is a used car price, X1 is a distance measured by an odometer, and then we have color to be white, silver, and other. Okay? So X1 is quantitative variable, but color is not, right? Color is a nominal variable. Okay, and it has 3 classes. Okay, it has 3 classes. So we can include only 2 dummy variables. Okay, x2 and x3 here. Why we don't need 3 variables? Can we have x2 to be 1 in white, x3 to be 1 as silver, and then x4 to be other, 1 without the color? then it's redundant, right? We need only two variables to distinguish these all three classes. That's why we do not need to include all k variables. We need k minus one variable. Okay. Here k is 3, then we need only 2.
0,
Okay. That means that if we have a white car, then x2 is 1 and x3 is 0. Right? And then for silver car, we have x2 equal to 0 and then x3 equal to 1. And for other, we have x2 equal to 0 and also x3 equal to 0. Okay, so we can distinguish these all three habits. Okay, so how to create a dummy variable in SPSS. In this SPSS 5, we have only 3 columns, Y, X1, and color. Okay, and color. But then we have to create 2 dummy variables. Okay, so we go to the transform computed variables again. And then, suppose I create the X2 first. Okay, so I put the target variable to be color white. And then, for the numeric expression, I put color equal to 1. Okay? If I put color equal to 1, I got the 4th column like this. Okay? You can see that the color is 1, 2, 3. Okay? But you cannot put color into the regression model directly. Otherwise, it will treat color as just a quantitative variable. Okay? That's why you need to transform. You create 2 more dummy variables. When you put the color equal to 1, they're going to compare. If color equal to 1, they put into the 1 as like true. Okay? And if not, this is like false or it gives you 0 as a value. Okay? So now you have 2 dummy variables. You have to create twice, one for color white and the other one for color silver. And then we include all of that into the regression model. Okay. Here, from this coefficient, estimated coefficient, we can write down the regression equation like this, right? But what you notice is that there is one variable is not significant. In this case, actually you can remove it out and then refill again. Okay. Remove color white out and then refit the model again. But every time you have to refit the model. You cannot just say that, okay, since color white is not significant, you can write down something like this and then you ignore this term. And then you cannot do this. You have to refit the model by exclude that variable out. Last part of our lecture. The model building. Okay. As I mentioned before, that if you believe that there is a set of independent variables that have a relationship with response variable y. Okay, but then usually the goal is not. The goal is to find the best subset of independent variables that can best describe y. Okay, so that is the goal. And sometimes we probably have like tons of independent variables, but we don't need to include all the independent variables into the model because it's hard to interpret. Okay, so we need, because as a parsimonious model, we need that You just need like the best subset